Hello once again. I would like to take this time just to walk through some of the technology tools at your disposal. Obviously, Desmos and MathCracker or any other app you find online is not the only sources at your disposal. Excel can do a lot of analysis for distributions. I think if you play your cards right, you can get it to work for chi-squared. Don't quote me on that. But I know you can do it for normal distributions, and I'm fairly sure you can do it for t distributions. Chi-squared gets a little murky for a lot of software out there, but I know for a fact you can do it on Desmos because I wrote it. So I know it works, unless it doesn't. But I tested it pretty extensively. Anyway, we have here four options: one for proportions, two for means, one if you're trying to find the mean with you not knowing the standard deviation of the population. That one's pretty common. In the rare off chance you do know population standard deviation, you can do the hypothesis testing for known sigma. And then for one variance, which also doubles as one standard deviation, because variance and standard deviation are just squares and square roots of each other, we've got this one tool here. So we've got three things to input, which is great because we've got three things we can input. First of all, the value of the standard deviation for the claim. Got to be standard deviation. So if you know variance or you had a claim to variance, you would type in the square root of whatever number. But since we were given standard deviation, or we found it, we'll type that in, 005. Sorry, that was for the sample. Whoopsie. For the claim, it was 006. For the sample, it was 005. And we were basing that off of 30 samples. So there is our chi-squared value. And here are our options for the p-value. We have the left tail, the right tail, and the two-tailed values for p-value. And since after we got that clarification, we were looking for less than 0.006, that means we are going to go for this p-value for the left tail. So let me check I got that in there, right? Yeah, 0.0111. That is based on our two-tailed test here. So that takes care of that. We can then make a conclusion for that one. In fact, let me go ahead and do that. We are going to fail to reject H0 on this one. That is because our alpha value was 0.05, right? 0.05. Our p-value is bigger than that, which means we had a pretty high chance of getting the sample we did with random sampling, given the null hypothesis being true. So we are unable to reject the null hypothesis, which might have surprised a couple of you. First of all, this chi-squared value looks pretty big. And also because our sample standard deviation we found was below the claim, right? It was below 0.006, but it wasn't below enough. So it was the 1-2 punch of the standard deviation being just barely below that threshold. And also 30 is not a huge sample size. But that's how you do it, start to finish. And this is going to sound a little weird, so hear me out. When you are doing these, I really recommend one of two things, especially for this section. When you're using this calculator or any calculator in general, especially this one though, you gotta be careful to either close out the calculator entirely and reopen it, or delete everything out and then start afresh. That is because you see these big scary symbols here? This is calculus, and I'm not going to teach you calculus because, well, calculus is kind of hard, but it's really hard for Desmos to do. And no joke, I cause Desmos to lag when I do a lot of these integrals, when I do a lot of these calculations, or when you make it do a lot of these calculations. So if you change these numbers quickly, it might take seconds to even a minute for Desmos to catch up and give you your p-values. So just a word to the wise there. But that's what you got to do. And that's a way of getting these p-values quickly. So here's our p-values.